Let's finish populating the array. So I'm going to add number sub 1. Let's make that a 10.3 again, and number sub 2 equals a 6.11. And now one way I could add the result is to say result equals numbers sub 0. And then on the next line, I could say result equals result plus number sub 1. And then, of course, I could say result equals result plus number sub 2. And then we could console.writeLine our result. Let's do a quick run to see if we get the right answer. So I'm going to save program.cs, start without the debugger. And down here in the output window, I can see 29.11, which seems like that's an answer that's in the right ballpark at least. So now let me show you a few things that can simplify this code. Let's start with the array initialization. If I know exactly what values are going to go into this array, so I know there's going to be a 12.7 and a 10.3 and a 6.11, I don't have to write these statements on separate lines like this. Instead, in C#, I can use what's known as the array initialization syntax to go ahead and tell the C# compiler, please put inside here the values 12.7, 10.3, and 6.11. So the syntax is simply using curly braces to denote a series of expressions that are separated by commas to say, I want a new array that can hold 3 numbers, and by the way, here are the 3 numbers. And notice if I try to add a 4th number into the array, I'm going to receive a compiler error. Sorry, you declared an array of size 3, but you're trying to put 4 numbers inside. So one solution to that problem is that when I know exactly what I'm putting into the array, I can once again rely on the C# compiler to do the right thing. So instead of saying that I want a new array of double that can hold 3 items, since I now have an initialization expression, I can leave the number out of the square brackets so I don't have to provide an explicit size. Instead, the C# compiler will figure out what size I need to hold these values. And now I don't need to write these 3 lines of code. So perhaps this code is a little bit easier to understand. Either one will work, but I want to use the code that is the most readable. Now, once I have this initialization expression, it turns out I also don't need to explicitly tell the C# compiler that this is going to be an array of double. The C# compiler can both figure out the type, the underlying type of the array, and the size of the array. So I can remove the keyword double here and just basically tell the C# compiler, look, I want a new array. Here's the values it's going to hold, and the C# compiler is going to figure out the rest. If I hover over numbers, I can see, yes, it's an array of double. So these are just little nice things that the C# compiler can help you with. You don't have to write so much code and be explicit about everything. So here's another shortcut by the C# language. Anytime I want to take a variable and add a value to that variable and store the result back into that variable, there's a shortcut expression I can use. So instead of saying result equals result plus numbers sub 1, I can say result and then use an operator known as the plus equals operator to say basically add number sub 1 and store the result back into this variable. So the line of code I had there previously and this line of code, they will do the exact same thing. And I can do that also down here. I can say result plus equals number sub 2. And now that I've added an additional number into the array, I'm not computing the correct result. And obviously it's going to be impossible to write code like this, where I address each member of the array individually, number sub 0, number sub 1, number sub 2. That code is going to be impossible to write if I do not know the size of the array when I'm writing the code. And that would be the case with an array parameter like args here. I don't know how many args are in that string array when I'm writing this code. Yes, I can check this length property at runtime to find out how many elements there are, but writing code like this is impossible. And this code also contains a lot of duplication. Essentially, what I want to do is add in a number to my result for each number that is in that array. And when I say for each, that's important because there's a number of looping statements that you can use in C# to loop over and visit each item in a collection. Later in the course, we'll talk about more of the looping constructs and looping statements that are available, but for right now, I want to show you that if you want to do something for each number in the numbers array, you can write what's known as a for each statement. So let's back out a few of the things we've done. I just want to say result equals, and let's say a 0.0. And now instead of explicitly adding these numbers, I want to write a for each statement. So the for each statement consists, first of all, of the for each keyword, and then inside of parentheses, I am first of all going to declare a variable that will hold the value of each item that is in the collection that I am iterating over. And I tell for each that I want this variable to work across the values that are in numbers. So I'm saying for each double number in numbers. Behind the scenes, the C# compiler will generate instructions that will visit each number that is in the array, so 12.7, then 10.3, and then 6.11, place that value into this variable number, and then execute the code that is inside of the for each statement. How do I place code inside of a for each statement? Just like how I place code inside of an if statement. So I use an opening curly brace and a closing curly brace to say for each number, execute the following code. What I want to do here is add my number into the result. I want you to try that, but before you go, I also want to point out that this value number, this variable, has to be typed appropriately. So if I try to say, pull out each string that you find in the numbers array, the C# compiler is smart enough to say, sorry, you're operating on an array of double. You're trying to assign a double to a string, and that's not going to work. So this has to be of type double. That would be explicit typing, but once again, I can use the var keyword to say, create a variable called number, give it the appropriate type, and just place each value inside. Now see if you can write the code to still compute the correct result.